One chip. OpenAI and Broadcom just put a custom processor on the table, built for one job: running large language models faster and leaner. To build purpose-built silicon, OpenAI needed a partner with deep manufacturing roots. Broadcom provides the physical foundation to take this architecture from concept to reality. This solves a roadblock engineers call the pilot-to-production gap. Enterprise AI projects often stall because the math of running sophisticated models on general-purpose hardware is simply too expensive for real-world features to reach users. Running a complex query through a generalized processor bottlenecks the raw data, requiring immense energy. Custom silicon changes the math. Tuned specifically for language models, every watt flows exclusively towards inference. The energy required for each output drops sharply. That efficiency scales up. Picture a data center where the hardware doesn't strain, but breathes through complex prompts with a fraction of the power. The hardware industry is shifting away from renting generic computing power by the hour, moving instead towards designing processors optimized specifically for language model workloads. Solving the hardware bottleneck in the server room forces the cost of intelligence to plummet. It gives the technology the economic freedom to move from the data center directly to the user. Falling inference costs allow sophisticated models to leave the server room and be worn directly on your face. A pair of glasses can now pull from a massive model without the latency that used to make wearables feel sluggish. This shift is visible in the new smart glasses from Meta and EssilorLuxottica. By embedding this capability into standard frames, high-tech computation becomes accessible consumer hardware. These interfaces move the intelligence into the background, where the model annotates the world in real time as a constant ambient layer. This visualization maps out Meta's plans for a new prediction market application. The interface tests scattered everyday hunches against live market probabilities and synthesizes thousands of predictions, turning isolated guesses into a single structured market signal. Wrapping models in everyday apps introduces new friction. As autonomous agents and cloned voices proliferate, people need a way to control their verifiable digital identity. This week, 11 Labs released an audiobook narrated by an AI clone of Michael Caine. Projects like this clarify why tools like the Human Consent Registry are necessary to ensure creators maintain clear authority over their likeness. As models become cheaper to run, the industry is focusing less on the raw power of the model and more on the container we put it in to make it useful and safe for people. All this expanding infrastructure ultimately exists to serve one purpose: amplifying what people can achieve. We saw a clear example of this from immunologist Daria Unutmaz. Unutmaz hit a wall on a medical research problem involving complex immunology that had completely stalled his progress for 3 years. He paired his domain expertise with GPT-5's reasoning capabilities, using the model to synthesize 3 years of stagnant datasets into a coherent, verifiable explanation for the pathology. Think back to the bottleneck in the server room. The freedom to iterate deeply on a 3-year research puzzle is only possible when the cost of computing inference drops low enough to allow continuous, open-ended problem-solving. When an expert can iterate through complex logic at the speed of thought, roadblocks that once took years to navigate start to move in days. From the architecture of a new silicon chip to the vast landscape of medical research, this infrastructure is lowering the barrier between question and answer. The capability has moved out of secret labs and directly to our front doors. So the real question now is what people decide to build once the tools arrive.